Hello, everyone, and thank you for joining us today for our first webinar of the year, which is also the first in our IRR and RPKI webinar series. I'm Emma Perrier, Training Coordinator at Afrinic. Tonight, we will talk to you step by step about the Internet Routing Registry from the zero to hero. Before continuing, we would like to know from which country you're listening. So I'd ask you to write in the chat section where you are. So we've got Warren from Australia, Patrick from South Africa, Zade Ranjit from Mauritius. Hi, guys. Kenya, Zimbabwe, South Africa, Willem, Malaysia. All right. So before continuing, we would like to know, I'm sorry. So now we're going to go to the heart of the matter. In order to ensure the success of our webinar, let me give you some house rules. First, please go to menti.com, menti, M-E-N-T-I.com, and insert the code 35431663. Menti.com, 35431863. So that's the code you need to insert. All the controls are at the bottom of your screen. For any questions related to the webinar, please use the Q&A section. For all other needs, technical problems, slides, sound, use the chat section. At the end of this webinar, we will be sending you a survey. This will help us improve our future presentations. So please don't forget to fill it out. Also note that this session will be recorded, and we will make the video and the slides available to you after you completed the survey at the end of the webinar. For this evening, our presenters who will be speaking to you are Olatunde, trainer at Afrinic. Dev Jinya is our IP number resource analyst who is also working at Afrinic. To ensure that you have a smooth experience, we have Bashir, another trainer of ours, and Willy Manga, our DO engineer, who will be providing support in the background. We look forward to a fruitful and enjoyable, above all, interactive session. The floor is all Ola.
Thank you for that beautiful introduction, Emma. So as Emma said, I'm Olatunde Obili, trainer here. And this short webinar session, Dev Junior, an IP number resource analyst here at Afrinic also, will be assisting me. So what is the agenda we have for you today? Today, we're going to look at a very short introduction to the Whois and how it integrates with the IRR, or how the IRR integrates with the Whois. And then we're going to spend some good quality of time investigating and identifying different routing registry objects. Now, because this is a webinar, we will not be looking at all the routing registry objects, but we'll look at the main ones. And the third item on the agenda, we are going to be looking at how you describe your policies using RPSL on our routing registry objects. And then finally, we will look at how you can create filters, prefix lists from IRR objects. And then there will be a short Q&A session where you can interact with us. So, the Whois and the IRR. As you see it here, we say it's the same difference. Basically, there's a very little difference between the Whois and the IRR. So what is the Whois service? It's basically a database containing various objects, from your maintainer to your role, Inet num, different kinds of objects. And you have different parties that interact with it. I'm sure most of you here probably are from, you maintain your own networks, you run your own networks. So network operators, whether enterprise or ISPs, interact with the Whois. We also at Afrinic do interact with it. And it's a query and response protocol, basically. And it's a database where we query to get certain information about your allocation or your routing information. And with this protocol also, we can insert objects into the Whois database. Now, this is a structure of a Whois object. You have on your left side, you have the attributes, and on the right side, you have the values of the attributes. So the value attribute pair describes a certain object, usually an object in real life. So you can have a person object, the value like the one we have here now. The value and attribute pair will describe a person. If you have an autonomous object, an autonomous system object, the attribute and value pairs will describe that real life object. Now, Whois objects are also interrelated. Okay, so in the example we have on the screen, you have an Inet num object, which is interrelated via its primary keys. Probably you're used to, you're aware of relationships in databases. And you can have multiple person objects related to another object within the Whois and a maintainer object. So the key concept here is that we have objects that are interrelated in the Whois service. Okay. So what is an internet routing registry? So it's also just like the Whois, it's a distributed repository for storing routing information in the form of attribute value pairs, like the objects we described earlier on. Okay, so IRRs are operated by different organizations, from RIRs like us, like Afrinic, government organizations, other hosting services do run it. And objects in the Whois database or the IRR are described using the routing policy specification language, which is not a routing protocol. It's a syntax you use to describe objects in the Whois database. Okay. And of course, it's publicly available, just like the Whois service. Anybody can go into it and query it. So why do we need a routing registry? Now we can express different types of internet number bindings. So for example, we can have a route object. That's the prefix you announce, and it's binding with the autonomous system that it originates from. You can also look at, you can bind it with your AS and the AS macros, which is a fancy word in RPSL for AS sets. You want to know the customer AS is behind your own AS. You can express that in the routing registry. Now, it's also, so another reason for it is because of its stability, consistency, and security. So why do we say stability? First of all, our routing registry, and like other routing registries in the world, are mirrored. We have daily updates from all the routing registries in the world. It's also secure. So for example, at least in the Afrinic routing registry, only resource holders can create route objects, for example. So you are certain that this route object you are looking at, you queried out of this database, belongs to an actual resource holder, not just anybody can create that. And also, you can also generate, which you will see later on in this webinar, you can also generate router configuration of filters from the routing policies that upstream or downstream providers have documented in the routing registry. Okay. So like I said earlier on, the database or the routing registry is mirrored. We have Afrinic there, and we can see we mirror the database with different routing registries in the world. Most of it is real time. Some do occur via daily dump, but most of it is real time. So I'm just going to show you just a short concept here, because we have both allocation and routing objects. Because some of you might not know you've been using the routing registry because you use the Whois service. So it's also basically the Whois service. And we have your Inet num, your Inet 6 num objects are your allocation objects, which are given to you when you request for resources from a routing registry like us. And then the route objects, the routing objects, are your route and route 6. Now you can see on the screen there that the autonum object cuts across both allocation and routing objects. So Afrinix Internet Routing Registry was deployed back in 2013, and it was integrated with the Whois service. Now, this was basically easier because the Whois database already contains maintainer objects, for security purposes, technical contacts, in-person objects, role objects. Now the routing registry was integrated into that. So now you have all your objects in one repository, central repository. You don't have, it's not scattered all over the place. And like I said earlier on, you have mirroring agreements with other selected regional IRRs. And I said some of them are via daily dumps and some of them are real time. And some of the members or adoption of the registry started back in 2014. And most of all, it is a free service that we offer. Now we have a few stats here showing the growth of the use of the Internet Registry by our members. You can see it's been a healthy growth, and the aim of this webinar is to see even a healthier growth. You can see the members, the registration of route objects in the database has been growing healthily over the years. But we can see here also that there's a slight difference between the Route 6 and Route 4 objects, the way they are split in the database. And I want to invite you again to go to menti.com. I hope you were there. And type in the code that Emma told you at the very beginning. There you go. It's just a short test to see if our knowledge about the next section.
So the question is, what IRR object is used in documenting a prefix and its originating AS? Less than 10 seconds.
Yes, because we're going into IRR objects now. I want to see.
29 people responded.
Ooh. Okay, we have our results. So the next item on the agenda is to look at the IRR objects, the different IRR objects, like I said earlier on. And like I said, also, we'll be looking at just a selected few so that we don't spend too much time on this webinar. So I mentioned routing specification, routing policy specification language earlier on. It's an extension of built off RIPE 181, which was getting a bit clunky to use. And you use it to define, when I showed you the object, the attribute value pair, that was RPSL basically. You were trying, you define your objects in the routing registry using RPSL. So the attribute value pair was basically RPSL. You can do more complex descriptions with it, which we will see later on. And it's what you use to express your objects in the database. And it is vendor independent and extensible, of course, it's open. So recall. So I don't know if you participants, can you please go to whois.afrinic.net? You will need to use that later on. So this is an RPSL object format, but the other time, this is a template. The other time I showed you a full object itself, but use your template to build the RPSL object. Now, remember again, you have the attributes on your left. I have the values. Now the type. Now the type could be different based on the three different columns you can see on the screen. So you can see that some of them could be mandatory. So that means if you don't insert those values, you can't create the object. Some of them are optional. We will see later on in different objects. Some of them could be, you take a value that is single, and some could be multiple in the list. So for example, you can add multiple phone numbers or multiple email addresses, but the name will be single. And then the key type for that value. So it could be a lookup key which you can use to query the object in a database, but the lookup key is not unique basically. But the primary key is a unique key to that object, and the inverse key is what you can use to search where that object is referenced within the database. So there are there are 8 actually Internet registry objects, but there are 4 if you combine everything into a Route 6, for example, an Utnum, an Inet router, and set objects. That's why I said there are 4. But if you split the set objects up, you see that you have actually 8 objects. So the Utnum object, one of the most important the routing registry object. Now it provides, so like I said, the attribute and value pair. That when you describe an Utnum, you're describing an autonomous system within the routing registry. Now, what some of the values in the routing registry, on the Utnum object, you can use to describe your policies, the policy for that AS. What routes are you accepting? What routes are you going to filter? And so on. So you have the Utnum object template here. So if you go to whois.afrinic.net, you can just you can search with the -T flag, and then Utnum. You will get this template you have on the screen. And as you can see, some of the attribute value pairs have been highlighted. So you can see the Utnum itself is a primary key and it's mandatory. You can't create the Utnum object without having that value there. Now, the member of import, import and export, MP export, that's MP, import and MP export fields are used to describe the policies for that AS. Okay, so this when you're describing your autonomous system within the routing registry, you use these fields to describe the way you announce or what you accept on the internet. Maybe Deb will want to shed more light on what you do with the maintainers, different types of maintainers on the Utnum object.
Okay, so here the ones highlighted in red, starting with MNT hyphen. So these are mainly maintainers, except the one in green, the MNT-IRT. That one, it's used to specify the abuse contact actually, and it is not really used for authentication. While the others, MNT lower, root, and MNT by, they are actually used for authentication. So lower would be used for authorization when creating hierarchical objects. So if you're creating, for example, an AS set, you would need to use the MNT lower. MNT roots, it's used for when you're creating root objects, so root and root 6 objects. Now the MNT by, this one, it protects the object itself actually. And if you query the Whois database, the Afrinic Whois database, for all allocations that Afrinic does, like all resources that we give to members, the MNT by would be Afrinic HMMNT. So that maintainer actually, it's the maintainer of Afrinic, so Afrinic host masters. And actually the MNT by, if you authenticate against it, you can do anything you like with the object itself. You can modify it in any way you like. You can even delete the object. So this is why all allocations, the MNT by is Afrinic HMMNT, because we do not want the members to go and maybe by mistake delete the object because they can authenticate against MNT by. Right? Back to you, Ola.
Okay, thank you, Deb. So another thing I want you to take note of, because some people think they can use the remarks. Well, they use the remarks section to describe the policy of the AS. No, you use the member of or the import section to describe your AS policies. Okay, we will see very soon along as we go on in with this webinar. So So as Dev said, you use those different maintainers for hierarchical authorization operations. So we will see that also shortly. We'll show you examples of that. So this is an example of an outnum object. Of course, this doesn't have any policies definitions in it at all. So you can see that it doesn't have any import-export attribute values there. But this gives you an example of an idea of what an outnum object looks like. So please go to menti.com again.
So the next question is what IRR object is used? No, this one is already done. You need to pass Ola to switch to the next one.
Yes. Let's have a leaderboard. Sorry.
So those are people who are very quick to answer. So the next question for you is which of these outnum object attributes are optional? So which of these outnum object attributes are optional? At the bottom, you have taxi, export, AS name, org, MNT routes, or MNT buy. Which object attributes are optional?
Okay.
Only 9 people so far. It looks like they are afraid to answer. Ola.
And then look at the previous slide.
We have 81 attendees. What are you doing? You just need to go to menti.com. You have the code and you give your answer. Okay, 35 people. I think when you reach 40, 45, Ola, you can stop and then give the answer. Two more people, at least. There you go, Ola.
Sorry, I was talking to myself there. So if you looked at the previous slide where we had the outnum object, you will see that you had the sorry. All right, so let's look at the Route 6 object this time around. So I remember in the last quiz, some people chose the outnum object because the route, actually the correct answer there was the route object because that's what you use to define both the prefix you announce into the interdomain routing mesh and the originating AS, okay? So the route object contains all information regarding routing announcement, basically. It's usually a superset of your Inet norm object. You create it from your Inet norm allocation from your IRR, and it's a CIDR value. Okay. So again, if you go to whois.affinic.net, if you do the -v route, as you can see here, you will see the template for a Route 6 object. Okay, and you can also see the different mandatory and optional fields within the object itself. Okay, you can see it's quite similar to the OutNum object, but it doesn't have, you don't describe your policies on your route object. It is the prefix that you are announcing to the internet, basically announcing out of your autonomous system. And you can see there's a field called member of. We will see how we use this later on with the route set objects. I think Dev has already explained also with the different maintainers how you use them on the autonom object. They apply the same way also here on the route object. Or you want to say more on that, Dev?
That's fine.
Okay. So this is an example, excuse me, of a route object. This is just the prefix you see, and the origin AS. These are the two highlighted keys there. And the same thing applies to a Route 6 object. You have the prefix, the IPv6 prefix, and the originating AS. Okay. Now, how does the route object relate to other objects in the routing registry? Remember at the beginning of the webinar, I showed you in the Whois, the objects are related. So you have your route object, and you have it's from your Inet num location, okay? And the origin is also related to an AS. So the primary key of the AS is the origin value in the route object. Again, we have another quiz for you. Now, before you start this quiz, let me I said go to, so I hope you're all at whois.afrinic.net because you need that tool to answer this question. Excuse me. Okay. So, next question. I hope you've all opened that.
The next, the next question is, what is the origin of the following route object? Based on the information you can query on the Afrinic IRR database, what is the origin of the following route object? Five more seconds, 5 seconds left. Only 16 people.
Oh, fantastic. Okay. So yes, that is if you query in the Whois database for that particular prefix 192.192.0/24, you will see that the origin attribute has a value of AS37301. Okay. So creating a route object in Afrinic, the Afrinic IRR is a bit it's straightforward, but it's a bit, there are different scenarios. So this section, we're going to show you different scenarios. So if this is our region covered by Afrinic, of course. If you have the prefix and your AS, your outnum resource from the Afrinic region, you can create your route object within the Afrinic routing registry. Okay. Now, if your prefix, your resource, your IP address resource is from outside our region, but your AS is from Afrinic, you will not be able to create a route object within the Afrinic routing registry. Okay. If you have your prefix from us, you get it from Afrinic itself, and your AS, your AUTNUM, is from outside the region, it is possible you're allowed to create your route objects or route 6 objects within the Afrinic IRR. Okay. Now, if you have both your AS and prefix outside our region, now that is, you are not allowed to create your prefix within the Afrinic registry. Okay. So, I think Dev would like to shed more light on the authorization hierarchy that you explained during the AUTNUM section to show you how that applies to your INetNum objects here.
Yes, so actually for when you're creating root objects, as Ola Tunde just explained, if the prefix is not issued, is not from Afrinic, you will not be able to create root objects in the Afrinic IO database. And why is that? It's simply because the authentication, when you're creating a root object in the Afrinic database, the authentication is done against the maintainer referenced in the INetNum. So if the INetNum itself is not registered in the Afrinic database, you will not be able to authenticate and create the root object, right? So it's only possible to create root objects for IP prefixes, IPv4, IPv6 prefixes that were issued by Afrinic. So in an INetNum, you have different type of maintainers. So here we have the MNT BY. As I told you earlier, most of the time, well, in all objects actually, which are allocated by Afrinic, the MNT BY would be Afrinic HM MNT. So this one is used actually by Afrinic hostmasters to protect the objects which we allocate to members. Now the MNT lower, it's used to create objects which are like one level lower. For example, for INetNum, you can create assignments. Just an example, if you have a /24, for example, and out of it, you're assigning small subnets, maybe /28 to customers, you can register those assignments, those /28s in the Whois database. And to create those assignments in the Whois database, you will need to authenticate against the MNT lower in the parent, so in the /24, which was delegated by Afrinic to you. And the other type of maintainer mentioned here is the MNT roots. So this one is specifically used to authenticate when you're creating root objects, right? So yeah, that's it. Back to you, Ola.
Thank you. So the next object we're going to look at, it's the Inet router object, so internet router object. So the summary of, the Inet router object is basically all interfaces within your AUTNUM, within your autonomous system. Okay, so you can also use it to define pairing relationships. If we in a more advanced course, we could show you this, where you can, particularly maybe at exchange points, you use your Inet router to define pairing relationships, and you also have a template for that. If you go on the Whois, you can see the template, and one of the key attribute values have been highlighted also here. You can see that the Inet router itself it's going to be a fully qualified domain name. It's not going to be R1 or R2 like you see in a Cisco textbook. All right. So the local AS will be it's mandatory. You put that there, and then the interfaces, and also the member of, because you have a router set. We're not going to look at that in the set sections today, but you have a router set. We use the member of attribute value to indicate what set this router is or belongs to. So this is an example of a router set, internet router object. You can see, like I said, the Inet router name itself is it's a full it's a domain name, right? You can see the local AS, you can see the interface address and the mask length is all there. And then the BGP peers, right? So look at a quick example of how that works. So you can see the router in AS2, r1.as2.net. This is the object for it. You can see the router name, or we can see the address, the different IP addresses of the interface, and the pair that it pairs with at the AS it pairs with it. Okay, so like I said, we're going to look at two main set objects because you have 5 of them. We have the AS set, we have the route set, we have the router set, the filter set, and the pairing set. But we will not look at the router and filter and pairing sets here today. But the AS and the route sets we will look at shortly because they are more popular. They are used more frequently. So one thing we need to look at, you need to keep in mind is that you can easily identify a set name in the routing registry by there's going to be a prefix and then there'll be a hyphen. So for AS sets, you're going to have AS hyphen. Route set, you have RS hyphen. Router set, you're going to have RTRS hyphen, and so on and so forth. Okay. So the AS set object, just like the name says, it's a set. It's a set. So it defines a group of ordinal objects. So when you want to, so maybe you have your service provider, you have a lot of downstream peers that connect to you that you provide transit to. You can put all of them, or you can put all of them, define all of them in an ordinal AS set object. Okay. And can also be referenced in an optom's import and export voice expressions. We will see that later on. You can see that your set object actually makes things much manageable, easier when you're defining your import and export policies on your ordinal object. So the template also, if you go through whois.afrinic.net, you look at the template for an ordinal object, an AS set object, template looks like this. So the key value attribute pairs have been highlighted here also. The AS set is mandatory. Now the members and the members by reference. This field is used to define the set. Okay, so when the members section, you will have other ASs defined there. Okay, so you can see here is multiple. So you can put multiple values there. And then the members by reference also, which is a multiple value, you put the maintainers of ordinals that you want to include in this set. We will see examples of that shortly. So this is one example of an AS set for AS Afrinic. I said AS set for Afrinic. And you can see the members here, you have 3 values, and one of them, AS-Afrinic.-DNS, is actually another AS set. So you can nest them. You can put another, you can reference another AS set within another AS set. Okay. So we want to let's drive the point home. So you have AS set king here, for example. Now you can see that set includes AS2. AS2 will be referenced here. The same thing with AS1. And like in the previous example, you can see that AS gene is an AS set. It's not an ordinal. So you can include that in the set and to define your AS set. And like the members by reference attribute, as I said, it's used to define sets. And it references the maintainers of an ordinal object. Okay. So remember, AS sets are a set of ordinals. You can create them 2 different ways, using the member of, which you can reference either an AS or an AS set, or you reference using the members by reference, which is the maintainers of an ordinal. So if you use the value keyword any, of course, it takes any. And this is another example of an AS set, which has the members by reference attribute value. So you can see here, this is actually a MNT, that's a maintainer. That's a maintainer of an ordinal. Okay. So you can use both of them, as you can see. You can use members and members by reference. So the members section has an AS and AS sets, and then the members by reference has the maintainer of an auth somewhere in the database in the routing registry. Okay. So we have an example here also. We have the AS set, AS king, and one of these members is AS1, which is referenced in the members section. And the other member is AS2, which we are referencing using its maintainer. Okay. So the next object we're going to look at in the routing registry is the route set object, which defines a set of routes. Now the thing is the route set. Remember, the AS set is a set of ASs, okay, autonoms, which you can reference either by the members by reference or the members or the member of set attribute. Now, route set is not a set of route objects. It's just a set of prefixes, okay? So because it's easy to mix that up because it says route set, yes, but it's not a set of route objects, just like you have the AS set, which is a set of autonom objects, okay? You can also use that to define your policies when you are defining your policies on your autonom object, okay? And it also references other route sets. So the template looks like this also. You can have the route set, it's mandatory. And then the members and the MP members are optional though. And they are multiple. That means they can take multiple values of prefixes, okay? Not route objects. So this is an example of one. We have the route set here, and we have the members and members by reference. Also, again, referencing maintainers, and we can see the members section. We reference you can use either a prefix, not a route object. I say that again, a prefix, and you can also reference other route sets which contain prefixes. Okay. So this is an example. You have this route set, RS Blanca, which contains these two prefixes by its members section. And it can be referenced in this route set Sagat using its name. Okay. Now route set Sagat has this entire prefix in it and these other two prefixes. Or you can just reference the prefix themselves directly within RS Sagat. Okay, so I kind of said something about AS, or if you want to know a set object within the routing registry, it starts with a prefix, depending on the type of set object it is, and then there's a hyphen, and then you can now put whatever name you want to put. So AS Olatunde for myself, AS-Olatunde would be an AS set with my name. But we have hierarchical set names. So when you have an AS hyphen my name, anybody can create that kind of AS set within the routing registry. Now, that doesn't make it that secure, but there's a secure way of creating routing registry objects, AS sets within the routing registry, and that's the hierarchical way. Now, this is an example of one. It follows the parent-child structure. So this, you can see, it's actually two AS sets, but this two combined together, AS-dev AS-ola is an AS set name, and AS-dev is the parent of that AS set, and AS-ola is a child of that AS set. Now, for you to be able to create this full name, this AS-dev AS-ola, AS-dev has to exist, and it's going to authenticate. It has to have a maintainer, and you can use the authenticate to create this full AS-dev AS-ola. You have another example here also, because you can chain it together. That's why it says hierarchical. So you have the parent again here is AS1, colon AS hyphen dev and then colon AS Ola. Now, if you want to create, so as you can see here, the parent of this set, AS set, is AS1 colon AS dev. Now, because if you want to create AS Ola, AS dev has to exist. Now, one of the things you need to understand here is that for you to create, let's say AS Ola from this, AS1 doesn't have to exist because it authenticates with the immediate parent. Okay, but you can chain this together. The same thing with route sets. You can do that with route sets if you want to. So let me show you an example because it might be a bit tricky to wrap your head around. So you have the AS1. If I want to create an AS set, it's not just a random AS, like I said, AS hyphen Ola. I'm going to use the maintainer lore. Maintainer, remember when Dev said it earlier on today. I'm going to use that to authenticate and create this AS set. Now you can see the name AS1 hyphen AS4, right? And I had to create it using AS1. So you have AS1 in the name already. It's an AS set. So when you see, so okay, there are two ways to identify an AS set within the routing registry. You will see the prefix AS hyphen and then some random name, which I can say anybody can create that. But when you see one that has the colon, a full colon, then you know this is created using the hierarchical structure. It has been authenticated in one way or the other. And if you want to create another set from this also, you have to, so you want to create the another AS set, you have to authenticate against the immediate parent, not AS1. Now, one thing you need to know here is that you can't have two ASs in an AS set name. So you can have, for example, you can have AS1 colon AS2. That's not possible. Okay? But you have an utnum followed by an AS set. Now you can have an utnum following that again. So you can have AS1 colon an AS set colon another AS. You can put that. All right, but you can't have two ASs together at the beginning. So you can have AS1 colon AS2. It doesn't work that way. All right, so going back to the top here again, we have AS1. For you to create this, a set using the hierarchical format, you have to authenticate against AS1. And the name format will follow, you have AS1, the parent of that AS set will be the first. Everything left of that full column. All right, so you have AS1 colon AS4. And then if you want to create another AS set from that, hierarchically, you need to authenticate against the immediate parent. Although the full name AS1 colon AS4, this is the parent actually. But if you want to create AS bar, you need to authenticate against just AS4. AS1 doesn't have to exist. Okay. Well, like I said again, you can have an AS at the end. Doesn't have to be, but you can have AS and an AS again. Now, this is very important. It's a very important concept because, like I said, anybody can create an AS set in the routing registry if you just use the conventional way. But if you do the hierarchical format, it has to be authenticated, and you need to understand the naming conventions of this concept. All right. So go right again. So you can create the AS set from an AS. You have to authenticate against the maintainer lower. Okay, and then you can create further AS sets from that hierarchically. All right. So there's a quiz on this. That's why I was harping on it. You have to go to menti.com again. Let's see how.
So who is at the top, Ola?
ProSol.
ProSol. Okay.
Okay.
So let's see for the next question. Next question for you. Which of these are valid hierarchical set names? The question is, which of these are valid hierarchical set names? You go on menti.com, 3543, 1863, and you give your answer. Which of these are valid hierarchical set names? Is it AS King, AS colon 40, AS 40 colon AS Lily, AS 40 colon A50, and so on?
Okay. So, all right. So let's look at this again together. Okay, people are still voting.
I think you can show the answer and explain.
Okay. So let's look at it together because it's a bit tricky to wrap your head around. AS King. It is an AS set. AS-King, sorry. That's an AS set. But it's not a hierarchical set. Like I said, anyone can create that. Okay? AS colon 40. That could be part of a what? No, it can't be a part of a MAC address. You have an S there. So, but that is definitely not correct because you have a colon before the 40. What does that mean? Now, this one where we have the high vote of 26, we have AS40, which is a valid AS name, colon AS set Lily. Now, this is meaning that for you to create AS Lily, you have to authenticate against AS40. All right. Now, this one, we have AS40 colon AS50. I think I was saying a lot about this. You cannot have two ASs to begin a hierarchical set name. Okay. So this is not correct. Now, this is the fifth one, right? We have AS30, which is a valid AS. We have the full colon and then the AS set Nina, which is a valid AS set name. And then you have full colon and AS40. That's another AS name. Now, strangely enough, this is correct. Like I said, you can have an AS name, somewhere within the set name, but it doesn't have to be. The first two cannot be AS. Okay, so this is correct. Now this one with AS1 colon RS Bruce, and this is AS3. This is also correct, but this is a route set, hierarchical route set. Okay, so it's which of these are valid hierarchical set names. So you can use that for route sets also. Okay, so let's see if Soul Pro is still there. Pro Soul. Okay, still the leader. So I said because we have I said we were going to we won't look at the pairing set. We won't look at the filter set and the router set. We just looked at the AS set and the route set. Now, this section we're going to look at how you describe your routing policies using RPSL, right? Because we did talk about the UTNUM object earlier on, and we said you define your routing policies using an UTNUM object and using the export and import attribute value pair within the UTNUM object. Okay. So, like I said, the pairing of policies of an AS are registered in an UTNUM object, and you will use both the import and export attributes. Though you have the MP import and MP export, I'm sure you saw it in the template earlier on. You can use that for multi-protocol to define policies for multiple protocols. Okay. So this is an example of an UTNUM object that has a policy defined in it. So you can see here we only use the import and export. And it's defined here that, okay, so what are you importing? So the UTNUM is a country. What are you importing into the country? All right, so from country AS1, we're accepting anything and all the goods, So, and the same thing applies to this AS3. Now, I'll share a link how you can understand some of these regular expressions, because you can use them also in defining your routing policies. Because you can see here, it's telling you that it's going to accept only routes that start with AS3, and AS3 can occur one or more times. Okay, so it definitely originates from AS3. And the same thing with exporting. What are you sending out of the AS? So to AS3, you're announcing all your routes, your full routes, and to AS1, you're announcing this two. Now you can, okay, we'll see later on, you can use something else there. We'll see later on. So this is an example of defining your policies. Like I said, what are you importing? What are you accepting into your UTNAM, into your AS? And what are you exporting? What are you announcing out? This is the most simple syntax in RPSL when you're describing your policies on your UTNAM object within the routing registry. You can see here also the MP, like I mentioned, the multi-protocol MP import and MP export, which is with RPSL NG, just like we have with NG and next generation. When you are defining for other protocols. Now, by default, MP export or MP import defaults to all. So, but you can specify. So here we're specifying address family identifier IPv6 unicast. Okay, so this is a way you can describe your V6 routing policies on your UTNAM. All right, so this is the structure of basically everything we saw in the previous slide. This is how it's constructed. Though it's still more complicated. Like I said, you can have MP. So the import statement, it defaults when you're pairing, it defaults to BGP, but you can't. It has the feature in a more complex form, not the simple one we are looking at now, where you can define different other routing protocols. You can even define route redistribution into BGP with that. All right. So the import construct for AS2, like I said, the AS2, an example here. So import from ASX accept any, meaning that AS2 will accept any announcement from AS whatever X, whatever it is. Okay. And the same thing here with I already mentioned the regular expression. Like I said, that it could be a bit confusing with regular expressions. Some other policies you might see. You will get the slides after the webinar anyway. So you'll see some of the references to the tools you can use to do that, to generate your regular expressions. So now scenarios for the import statement. So you as an ISP, you want to acquire connectivity from your transit provider, your upstream transit provider. And then you will accept all internet routes from your transit provider, of course, that's the case. And then you will accept all legit routes. All legit routes from your customers, routes that are generated from your customer, your downstream customers. So we'll look at that in this scenario. And you use AS2, our ISP, as the point of contact here. And our transit provider is AS1. And we have these two sort of downstream customers. So you can see in the UTNAM object, our import statement is saying that we're going to accept from AS1, the transit provider, the green one. We're going to accept any, that's the full internet routes from your transit provider. And then from AS3 and AS4, your downstream, your customers, you're going to accept routes that originate from them. That's why the regular expression is saying, the caret and AS3 and AS4 also there. So you only accept routes that originate from your downstream customers. Now the export statement is also the same way, okay, where you can apply a filter. This is basically you can apply a filter or a filter set. We didn't discuss the filter set, but you will see it in the slides when you see the slides after the webinar. So this one also, it could be more complicated when you want to do redistribution and all that fancy stuff. And this is the construct using the AS2 as an example. So if you want to export to AS2, you announce everything from yourself, okay, your full routing table. That's what you're saying. And then if you want to export to this to this filter, which it's not a filter, so you generated it. You're going to announce AS2 will announce only routes that originate from its downstream customers, ASS to SX. Okay. So, excuse me, scenario for export statement is the same thing. We're going to just, so an ISP wants to announce the routes of its customers to its transit provider. Yes, you want to provide transit for them also. And then you will announce all internal routes to your customers for them to be able to have, what they're paying for to you. So the same example here. We have the ISP AS2 and the transit provider and our customers. And you can see here, so we're to AS3. Remember the construct I showed you, the simple way of constructing policies on your AuthNum. Remember, we're doing this on an AuthNum object. So to AS3, you announce any. And AS4 also the same thing. You're giving them the full internet routes. And then to AS1, your transit provider, you're announcing yourself and your customers. All right. Now this is that's so I wouldn't call it a very the right with you get the job done, but it's not an efficient way of doing the job. It's not an efficient way. So, but here we can see now we've combined both the import and export route statements on our AuthNum object. You can see that our AuthNum has gotten fatter. And this is what we want to work in a lean way. You don't want to be writing too many RPSL statements on your AuthNum. And that's where the set object comes in place. So recall the AS set object. It's used to group, like I said, used to group ASs together, AuthNum objects together, usually your downstream customers. Okay, so usually maybe you have the same policies for them. You can group all of them into an AS set. Remember, using the member of or members by reference attribute. All right. And like it says here, it becomes very handy. As you can see, the AS got fatter in the previous slide. When your network becomes, starts scaling, you might need to start adding an import and export statement in your AuthNum object for each individual customer. You don't want to do that. And this is where the route set comes into play. So we look at that in the same scenario again, our transit provider and our ISP of the customers, excuse me. So we've defined the AS set and we defined it hierarchically. So we have AS set, remember, AS2, we're looking at AS2, we have the ISP here. And you can see we have AS hyphen customers. So that is the AS set, it's hierarchical. Okay, we have to authenticate that against AS2, the AuthNum, the maintainer lower, and the AuthNum AS2 in the routing registry. So we've defined the members A3 and AS3 and AS4 as members of this set. All right. So now you can see our AS policy definition has made the AS linear again. So in this case, again, our import and export statements all there. So in the import statement, we're saying we're going to accept any from our transit provider. And here again, so from AS2, this is the AS set, AS2 colon AS customers. From the AS set, that's AS3 and AS4, we're going to accept, see, we're using the regular expression again on the AS set. So you can see we're saying we're going to accept routes that originate from AS3 or AS4, but we put all of that within the AS set. All right. And then again to where we're exporting now. So we want to export also all the internet routes to our customers into that AS set. That's what we're defining here also. And okay, and to AS1, we announce ourselves, AS2, and the AS set our customers. All right. Okay, so you can see how the AS. So now here, if you get a new customer, you don't have to edit anything on your AuthNum object. You just need to go add the customer in your AS set. All right. So we have another quiz.
Next question for you. What RPSL set object will be best for filtering IP prefixes? What RPSL set object will be best for filtering IP prefixes? You have 4 options. Is it AS set, route set, RTR set, or peering set?
Okay, you have your answer there already. So we will use the AS set to filter, ASs. All right. So we just because for the sake of time, I will have defined a policy using the router set also. You can use that within the outbound object. All right. But we didn't do that. So it would seem
Also still the best and even the fastest.
Wow. Okay. So right. So now we discuss the last section, which is creating filters using the routing registry information. All right. So this is it's just an example, to highlight how this is done. So AS1, which was the main thing, the AS we are focusing on in this diagram, will require its downstream providers, downstream customers, AS2 and AS3, to register their route or route 6 objects in the routing registry. Okay, and as Dev said, if you need to have that resource allocated to you before you can do that. And so I am okay. If I see your route object within the registry, I know for sure that this is genuine. Now, for me as the AS1 myself, I'm going to register my UTNUM object in the routing registry. I'm going to register my route or route 6 objects in the routing registry. And I'm also going to, as you can see, I will need an AS set because I have multiple customers behind me. Okay. So let's say, for example, we're looking at AS2. What is the routes and route 6 object going to look like? So you can see based on the text from AS2, you can see the route 6 with the prefix 2001 DB8 and all that /48 is defined there. And the origin is AS2. That's a route object, route 6 object. The same thing for their IPv4 prefix. The origin is AS2. They've defined both in the routing registry. You see, transit providers or upstream providers will always look at they'll look at the routing registry for information also before they pair. So AS1 on its part, we're going to also register our route object, our v4 block, and our that we're announcing, and our route 6 prefix in the routing registry. As you can see also, it's the origin is AS1, origin is AS1. Remember that exercise, which you did? You have to go look at the origin to know the AS. And we will define an AS set hierarchically, best practice. So we have AS set again, and we have AS1, and then AS set customers. We are authenticating against our UTNUM object, okay, to create that AS set. No, anyone can create that AS set. Now, we also have a different AS set because if you remember in the previous section, when I was announcing my routes to my transit provider, I announced that my AS set for customers and my AS, okay? But in this case, we create another AS set, which includes AS1 itself and the set of its customers, okay? We register this in the routing registry. And then we will define our UTNUM policy in the UTNUM policy. So you can see here we're using MP import and MP export because we're dealing with both V4 and V6, okay? All right, so remember NP import and NP export, it defaults into all the protocols to accept them, but you can specify, like I did with the address family identifier IPv6 unicast. But you wouldn't use import alone here now because there's v6 there, because import is for v4. So here, what are we importing? So if you remember in the previous slide from AS1, this is the AS set for our customers. All right. So what are we accepting from them? Now, this is a keyword in RPSL, which we didn't discuss, but it's basically used to pair, it's for your pairs. So you can see we've merged our downstream, or the two these two ASs, AS2 and AS3, are defined in that policy statement. All right. So, and also again, we have it in a regular expression, the filter there, which says that it must start with that AS. The AS must originate. I mean, the prefix must originate from that AS, either of those ASs anyway. All right. And they can occur. The AS number can occur more than one time. All right. And then who are we exporting to? Our customers again. We're announcing our full internet routes. And then from our transit provider, which is AS100, we're accepting any. And this is a filter set. We didn't discuss it, but you can filter bogans because they want bogans. All right. And then we're announcing now, what are we announcing to our transit provider this time around? We're announcing that second AS set we defined, which includes our AS1, and our customers. All right. So this is also another way of, writing your policies efficiently. So when you've defined your policy within the AS autonomous object, you can create filters using specific tools. Now, the other tools you can use to create full BGP configuration, but we're not going to show that today. But there's a very simple tool available on Ubuntu. I'm not sure if it's available on Windows, but you use it to create filters. Whether it's a Cisco iOS or Junos, you can create filters for that. So, and that's BGP Q3. So, and looking at AS1 as the focal point also, we can use BGP Q3. Okay, you can see the simple command there. You're specifying here that it's v4. You want to create a filter for v4 prefixes, and this flag. Now there's a man page for that, which I will share also in the slides that we will share with you after that, where you can understand what all these flags mean. But this flag means, it's for you to define the name, to name the prefix list, and then you cannot define the AS set. Remember our AS set all we defined earlier on, and you can see it will automatically generate a prefix list, the prefix list with that name, AS1-v4. And the same thing applies to the V6. For if you want to create V6 filters also, you just have to, we define it, the flag, we've defined it as 6, and we've named it AS1v6, and then we insert our AS sets. So now, I think Dev would like to show you a short demo of how that works.
Okay. So, yes. BGP Q3. Actually, yes, Olatunde, it's not available for Windows, but those using Windows 10 can maybe use the subsystem to install it. So, okay. So this is actually the syntax. So you can see here that that's the syntax, right? And you can generate configuration prefix list for Cisco, for Bird, for Juniper, even for Huawei. So by default, actually, it will create, if you don't mention those flags, it will create configuration for Cisco. Right now. So in this example, I'm going to use an AS set. So AS set for Afrinic. which I have a look at it. Okay, so you can see these are the members. There are actually 2 AS numbers and an AS set here. So actually BGP-Q3, when you use it to create prefix list, it will actually look up all the root objects where these AS numbers are set as the origin to generate the prefix list. Now here we have an AS set, so it will also go into that AS set and look for the ASs which are members of this AS set and also include those in the prefix list. So let's try to create a prefix list for also one thing that's important, by default, it will, well, the way it is coded, it will use the RDB database to fetch the objects. Now, remember Olatunde explained earlier that the Afrinic database is mirrored and also RDB. So it's near real-time mirroring. So if you're creating your objects in the Afrinic IO database, it should be, when you're creating RDB, it should show it up in a few minutes or even seconds. So when using BGP-Q3, you need to mention here the flag S followed by Afrinic. I'm actually specifying the source. So I want it to use objects from the Afrinic database. So basically the objects that already be mirrored from Afrinic, right? So I want to name the prefix. Let's put a name. And then the AS set. So let me hit enter. So now it will look up all the root objects and generate a prefix list. Okay, so now here you have around 12. You have 12 different lines. So each of them actually match a root object with the ASs mentioned in that AS set, in the AS-Afrinic. There's another interesting flag, A capital. It will actually aggregate the prefixes which can be aggregated so that you have fewer lines and it's easier to manage. So one important thing when you are using these tools to generate your prefix list, don't just do it blindly and copy paste it in your production network. Be very careful, check the syntax, check if you're not missing out any important prefix so that it doesn't like affect your production network or your traffic in a way that you do not want it to. You can also create prefix. If you just look up the root 6 objects where the AS numbers are set as origin, right? Now, as Olatunde mentioned, the BGP-Q3 does not will not generate full BGP configurations. You can look into other tools such as IR toolset or IR power tool, but these tools are really complex to use. You would find very few examples, and well, you will have basically need to do a lot of trial and error to get it right. But this one is quite popular, the BGP-Q3. It's very easy to use, but since it relies on the root objects, you need to ensure that you have root objects created for all the prefixes which you're announcing, right? So every time you get a new allocation from Afrinic, do not forget to create your root objects. And the root object should also match to the prefix that you have for when you're creating the root object. The prefix should match the exact prefix that you have in your BGP configuration. So if you have a /22, which you deaggregate, which you have deaggregated and announcing like in /24s, you need to ensure that you have root objects for the /22 and also the /24s, so that when you use these tools to generate the prefix list, you do not miss out the more specifics. Yeah. Back to you, Ola. Thanks.
Thank you. So, thanks for that demo, Dev. So we do have a deployment support help desk, which you can access through this link. Don't worry, you'll get the slides after the survey. You fill the survey for this webinar, you can have access to it. And of course, it costs you $0 for us to assist you with creating your different objects within the routing registry. Okay, so we're going to go to the Q&A sessions if there's any. If there, entertain any questions.
Yeah, I think there is a question. Maybe one of you can answer. I just read the question. The question from Patrick is asking, is there a query to see all objects owned or maintained by a maintainer or an auth by default without it being part of a set you manually create? So he's asking if there is a query that you can use to see all the objects maintained by a maintainer without being part of a set.
Yes, so you need to do an inverse lookup. So maybe I can share my screen.
Yes.
So, but now then I'll need a maintainer object to look up. Okay. Let me look for that SIGCOM's AS number. Oh, sorry. I'm just querying it to have the maintainer. Okay, seems like I haven't. Right, so let's use this maintainer, for example. So if you want to look up all the objects that are protected by this maintainer, you would use this syntax. You do an inverse query. Now, you need to, so here I'm doing an inverse query to find objects in which SIGCOM-MNT is the MNT by. So, right I will see now all the objects which are protected by MNT by SICOM MNT. All the objects, some maybe SICOM MNT, maybe the MNT lower, but not the MNT by. So you'll have to change the key, the search filter here to match either MNT by, MNT lower, MNT domains, etc. I hope this answers your question.
I think it should be okay for Patrick. If there is another question, you maybe will ask it later on. So Ola, we have another question about your slide. Paul was asking on slide 106, if you recall, if you can explain a little bit the meaning of accept peer AS and the expression, the regular expression that you had.
Yes. So if I recall, like I said, the peer AS is a keyword in RPSL. Remember, RPSL is a routing protocol specification language. That's what we use to describe our policies on those different objects. Even the objects itself are written in RPSL. So it's a keyword which you use to match your peers. So in that example, the peer AS was for describing AS2 and AS3. Okay. Now you have the and keyword also, because RPSL has some reserved words like any programming language which you cannot use. So and so this the two downstream customers and the filter, that is the regular expression, must match. Okay.
Okay.
So
okay, thank you.
The pair is to merge the two of them, and then that the and then the filter is the other one is the filter to filter whatever you're going to accept from them, and it's a regular expression.
Okay, thank you. I hope Paul has his answer. Someone was asking briefly if we can explain the ROA. When he say ROA here for the audience, he's talking about the RPKI. Yes. Can you guys just give a very short explanation of what is all about? Very briefly.
Well, this is so if you remember at the beginning of this session, we said this is part of the IRR RPKI webinar series. Now this is the foundation, because you need both of them are interwoven. Now ROA is basically a route origin authorization, which is it's a way to know, okay, to confirm or certify that this particular route belongs to this member. Okay, it's it's cryptographically signed. Sorry. So the next webinar series, we're actually going to talk about more in depth into RPKI, which is Resource Public Key Infrastructure, and then we discuss further into ROA, because you cannot talk about ROAs if you don't have the IRR at first. Okay.
I hope it's okay. We have a general question from Oronti. He's asking how reliable is the IRR database?
Well, maybe there, but to the best of my knowledge, that has never gone down since 2013.
Yes, so if the question was how reliable is Aphonic's IR database, that's right. So more than 99% uptime, right? But now the IR system itself, it's not that reliable. Why? Because it's not only the RIRs that maintain IR database, the IR databases. There's RDB as well. So RDB is not an RIR. Anyone can go there and create root objects for, create any root objects for even prefixes that they do not own, they do not manage. So in that sense, it's, I would say, less secure compared to RPKI or what we were talking earlier about ROAs. Because ROAs, the certificates are issued by the regional internet registries only, and it's more secure in that sense. So only the legitimate holder of those prefixes can issue ROAs compared to root objects, right? But now, if you see you have prefixes from Afrinic, you see someone else has created root objects in RDB without your permission, you can always reach out to RDB and ask them to delete those. That's perfectly doable. But yeah, in short, RPKI is more secure than IRR.
That's true.
I hope that answers the question.
Thank you for the explanation, Dave. And like we were saying, there will be another webinar around RPKI and everything around Whois. So we have another question from Paul. Why do you not create route object automatically for corresponding Inet objects? So this is a general question. Why do you not create route objects automatically for corresponding Inet num object?
Okay, so actually, to manage and create the root objects, we leave it up to the member to do that, because actually the root object should match the announcements, your BGP announcement or the prefixes that you have in your network statement in your BGP configuration. And we don't know that. We won't know your exact routing policy, which exact prefix you're announcing. So we don't want to have all kind of object on the database. We want it to be to reflect the actual prefixes that you're actually announcing, not just like covering your whole range of IP prefixes. But now this is a feature that we are looking into. We want to implement that, so to make it simpler for members to create root objects and also Whois. But this would be in future release of the Marshonic portal that we have, where members can manage their objects. So in the future, we will have like easier ways to generate or to auto-generate root objects and Whois. But at the moment, it's not the case. Sorry about that.
Thank you, Dave. But we can say at least that in the current version of MyAfrinic, at least for those who want to use the web interface, they can, when they log in into MyAfrinic, they have at least a way to create, let's say, easily, or it's more easy than someone who can use the command line interface.
That's true.
So we have another question from Patrick. Is there an API into Afrinic to create objects?
No, at the moment we do not have any external APIs, but you can use email updates. So you have the RPSL object in an email and send it to auto-dbm@afrinic.net. So in the RPSL object, in the template, you'll have to include your password and everything to match the authentication. But any external API which connects to our systems, no, that is currently not supported.
Thank you, Dave. I think we are done for the questions, unless there are someone else. Once again, we remind you that this is a series of webinars. You will have another one coming soon about RPKI and Whois. In the meantime, at the end of this webinar, we remind you to answer the survey that you receive. And after that, you receive all the materials, the document, the video. I see another question. We will answer to that one. Anna is asking, what happens if someone enters an incorrect prefix in the route set? What happens if someone enters an incorrect prefix in the route set?
So, well, if it's an invalid CIDR, that the prefix size is invalid or the syntax of the IP prefix is not correct, it will not allow you to create or to update the root set with that prefix. But now to generate your configurations, as I mentioned, if you have put a prefix that is not supposed to be there in the root set, when you're using the tools to generate your filters, you need to cross-check what is there before just copy pasting it in your configuration. You have to be very careful. But then if you've added the incorrect prefix, you can always modify the object and correct it.
Oh, thank you, Dave. Do we have another question? Ola, I think we are done.
Okay. Thank you very much, all of you, for attending this webinar. And thank you to my colleagues also providing support for this webinar. You will see us, I think it's, this is when March, right? I think in that'll be May. There'll be something coming around for RPKI. All right. Thank you very much again.
See you.
Nice.
Bye-bye.
Bye.
Thank you. Bye-bye.